Hey, how's it going? In this video, I'll be covering how I made a turn-based strategy game. This is going to be based off the popular mobile strategy game Star Wars Galaxy of Heroes. And what we're first going to do is take a look at what that game is and what core functionality it has. We'll take a look at how I recreated that in Unity and go through a quick demo. And then we'll dive into the code and the scriptable objects that I've created to help me very easily put together this demo in the span of about a week in my personal time. So let's take a look at an example here. We have some gameplay footage of Star Wars Galaxy of Heroes, and we can see that we've got a team of 5 player characters versus a team of 5 AI controlled characters. Each character has a unique definition of who they are and how their stats grow, and they also have a level associated to them that multiplies against the stats that they have to bring about what their current power level is now. And we also see that at the bottom right corner, each character has a unique set of abilities that they can use to reduce damage to an enemy, heal their team's health, or apply some buffs or debuffs. So if we take a look at this now, we see that Darth Vader comes in swinging, and we see that each of the characters are taking their turns in order of whoever's turn meter reaches 100%. The turn meter is represented in blue above the character's head. So as the character reaches 100%, that's when they take their turn and execute an ability. And each character has a basic ability, which is the leftmost ability in the corner, which they can reuse every turn. But their special abilities, which are the abilities following the basic one, all have a cooldown applied to them once they're used. And this could be for however many number of turns, depending on the ability. So that's a quick demo of the gameplay, and if we move to this frame here, we can see that for every given character, they could have a level, a star rarity, a set of gear applied to that character, modifiers, and you will also notice that every single ability on the character actually has its own level associated to it too, so that two characters can have they could be the same character, but they may have different level versions of their own abilities being used against each other, all to eventually sum up to an overall power level. So this is what we're going to be, what I've already tried to recreate to some extent in Unity, and here we are. If we enter play mode, we'll see that once it gets in there, each of these enemies execute their turns after my guy has executed his turn. I think I've adjusted some of the speed values. So we'll move in here and we'll select an enemy to target, and I can either use my basic ability, which just does some damage, or on this instance of my ninja, who now has 100% turn meter, he could use his special ability, which does a sick animation, and pow, that guy's dead. And if we eventually cycle round back to this instance of the ninja character that used the special ability, we will see that, the ability now has a cooldown of 2 turns remaining. So I need to play for another 2 turns of this character's time until they can use that ability again. And combat continues until eventually one side is defeated. The samurai can heal himself because he's kind of a tankier dude, and that's the basic game loop that I've recreated. So that was the gameplay, and it all centers around a character definition. So this is an abstract scriptable object I've created, which was written with the intention of separation between an instance of a character and what defines that character. So what do I mean by this? Well, in Star Wars Galaxy of Heroes, you could have Darth Vader in your team, and he is of a certain level and has these abilities, and he's got these animations and so on. But you can also have another instance of Darth Vader on the enemy team. So that instance still needs to refer to some of the same data as your instance, like the abilities, what his animations are, what mesh he's using, and any other unique things to Darth Vader. But it also needs a reference to per instance data about that Darth Vader versus mine. So my Darth Vader could be of a certain level, and the other one could be of 10 levels higher, but have a lower level ability. So I've coded this distinction into my version of the game here, where we've got a character definition who's got a type, be it a attacker, tank, or support. They've got their core stat growth and their base stats, and they also have a reference to an ability, a list of special abilities they have, and an animator override controller. So let's break this down. So every single instance of a character definition, which is a scriptable object, which you can find in the project files here, has all of these values associated to it to define how strong the character is and how much health they start out with at level 1, which gets added onto as a flat value as they level up. But they also have an animator override controller, and this was actually the one thing that I didn't know about Unity going into this project. Animator override controllers are super useful because what it allows you to do is define a single animator controller that defines the state machine of your character. So it defines the individual states, the parameters of the state machine, and the conditions under which a given state would transition to another. But you don't necessarily need to use the animations placed in each of these states. So the example in this case is if you have all of these characters that basically do the same thing, right? In terms of their animator state machine, they all have an idle, and under the same conditions as anyone else, they all move forward, die, execute their basic attack, and execute their abilities, and show a hit animation, all under the same conditions. The only difference is the animation itself is different. So what we have is this base character animator, which is applied to all of these instances in the scene anyway, but the definition of the character, which I use as a reference to define their stats and stuff, also contains a reference to the animator override for this character. And taking a look at that, we see, well, it's not quite obvious with the ninja because the base animator is referring to the same animations. So I'm effectively overriding these original animations in this animator with the same animations. But that's in this case. For the example of the tank, this is a lot more clear. We see that it's using the same animator controller, but it is overriding each of these animations found in these states with its own animations. And that's all you need to do. And this can be reusable this idea can be reused in like a fighting game or a platformer where characters behave the same but they animate differently. It's so useful for that. Moving on, we come to the abilities of a given character. So that takes us to the ability class, which is also an abstract scriptable object, which contains the name, description, the sprite that would eventually go into the bottom right corner to act as the icon for the ability, and a abstract coroutine called execute, because no matter what ability it is, be it a buff, a debuff, a heal, an attack of some kind, all abilities would generally need this information here. Who's using the ability? Who's the target of the ability? Who are the allies of the current user of the ability? And who are the enemies of the current user of the ability? Because it could be an AoE, it could be whatever, right? So this is the minimum information needed for any ability to execute. And I simply inherit from ability to define instances of unique abilities. A special ability just has this extra field here, maximum cooldown turns. So if we move on to the basic attack of the tank character, we see that we use this information by first triggering their basic attack animation, which if we notice here, it's all the same parameters which are being reused across all characters, so I can rely on this information being completely static. And And if I were to not change this, I could even create static strings in my code that I could just refer to here so that I don't have any chance of basically introducing a typo in my code. So I trigger the basic animation, wait until the animation is complete, and I do this by actually taking advantage of a behavior applied to the animation state, because again, it's the same animator controller across all characters. So I take advantage of this script here, which basically just sets a boolean when the animation finishes to tell me when the animation's done. At that point, I play the hit animation on the enemy target and apply the damage to that enemy. So it's pretty straightforward, but it sets up the framework for defining unique behaviors for each ability in the game. Because as we see in this example here, each ability does something weird and wonderful and crazy. Like that one, for example, that character didn't even attack. She invoked another ally character to give an assist and attack the enemy for her. So all of these custom unique behaviors are made possible with scriptable objects and abstract coroutines that you can override to implement that unique functionality for the ability. At the same time, because at the character definition level, it's just referred to generically as an ability or a list of any special ability, you could hot swap the references to your scriptable objects. So if I come to this tank definition here, we see that our tank has a reference to this animator override for his unique animations, a reference to his basic ability, and a reference to a healing ability and a special taunt. But if I wanted to replace this taunt ability with the special attack of the ninja, that's all I needed to do. Now the samurai will execute the ninja's special ability for that ability slot there. However, with the approach that I've used, just because I swapped the animation, just because I swapped the ability, does not mean I swapped the corresponding animation with it. So that's kind of a limitation there. The abilities themselves don't carry with them the animations. But is that a disadvantage? Is that a feature? Who knows? Moving on, we then take a look at I guess we can take a look at the instances of characters. So in the scene view here, we can see under this empty game object, we've got every single character in the scene. And each of these characters have a character instance monobehavior on them with a reference to their character definition. And we can notice here, each character has a reference to a common definition. So two ninjas can refer to the same ninja definition, in this case not. Let's fix that. So these two ninjas here refer to the same scriptable object definition that describes all of their stats, all of their animations, and all of their abilities. Great stuff. But between them, one is level 40 and the other one is level 1. So we can see how this distinction between definition and instance becomes really advantageous, because I mean, you could have multiple instances of a character that have differences between them, and this is how I control that. So now that we've covered the character instance, I guess we can move on to this monobehavior here, the code for the instance itself. And it's pretty self-explanatory. It has a lot of public methods that do the things you expect it to do, like take damage, restore health, blah blah. And on start here, we can see that we grab a reference to the animator controller component and set its runtime animator controller to equal the character definitions animator override controller. So it just assigns that, and then bang, the animations have changed. But apart from that, this monobehavior itself doesn't drive itself per se. There's no update loop here. There's no receiving of player input in this class. Instead, where the magic happens is in the combat manager. So if we come to the combat manager here, we see we've got references to the player's allies and the player's enemies, some UI references, and here it is, a private queue of character instances, which I call pending turns. So at start, we trigger a coroutine for the combat sequence, which is a while loop that continues forever while the combat manager understands that we are in combat. So if we are in combat, then we check how many pending turns there are, how many characters are waiting to execute their turn because their turn meter has reached 100%. So if that is 0, we see that we actually have a nested while loop here that iterates for each character. If they're not dead, update their turn meter. So it continually updates all turn meters for all characters evenly according to their speed stat until one of them has at least 100% turn meter, in which case that character is NQ'd to have their turn executed next. Already, you can actually see there's a disadvantage here because if 2 characters reach 100% turn meter at the same time, because this loop loops through the enemies first and then the player characters second, it will always prioritize the enemies taking a turn in front of the player. Now, I intentionally did this first because I just wanted to see, is the character that I expect to take a turn first going to take a turn first, especially if their speed stats are the same. And interestingly enough, Star Wars Galaxy of Heroes actually had a recent update where they addressed this issue, because in their game, when something like this were to happen, the 2 characters, the game would basically randomize which character took a turn in front of the other. So there wasn't really any determinism in which characters would take a turn. In mine, at least, there is some determinism, and in their patch, what they introduced was a system where if 2 characters have turn meter, it actually defaults to comparing which character has higher speed and prioritizing that character to go first. And because I have a speed stat here, in principle I could do that as well instead of this linear loop. So moving on, we come back up here. So we assume that we have a character that's pending a turn, and we check if that character is not dead, because if they are dead, and it's possible that they can die with 100% turn meter because 2 characters took a turn at the same time, or had their turns at the same time. One went first and killed the other, and therefore this character, although already in the queue, needs to be DQ'd from the turn-taking process. And at this point, when there is a character to take a turn, then we wait for them to execute that turn. If it's an enemy, then in my case, I'm just randomizing a target and just using the basic ability. But this would be a point where you could potentially use another scriptable object as an example of the strategy pattern to inject some behavior to that character so that they can do some unique decision making at this point here. An example of that would be like you could make a scriptable object for a tank brain that would prioritize using their like self-healing and tanking abilities over attacking other enemies, or a healing strategy for a healing character that would prioritize using their healing abilities when their health or an ally's health is low. Stuff like that. This would be where that gets injected. And using scriptable objects in conjunction with the strategy pattern is a really good way of introducing that unique character AI from character to character. Because in Star Wars Galaxy of Heroes, I know for a fact Darth Vader always takes good advantage of his unique abilities when those abilities are available to him. And as a result, you can notice that he behaves differently compared to, say, Grand Moff Tarkin. So that's a clear example of the strategy pattern, and how that's made possible with, or potentially with, scriptable objects. If they're not using scriptable objects, I'd kind of be surprised, but I mean, it's possible without, right? So then we come to what's this? The player themselves taking a turn. So at this point, if it's the player's turn, we refresh the UI, which if we come down here, we'll see that we iterate for each of the characters' special abilities and enable buttons in the UI to allow them to use those abilities. Additionally, because I have references to the icons for individual abilities, those icons can be applied to the buttons. We even see here, I have an initialized button already where it takes a reference to the ability and takes the sprite and assigns it to the UI button. But at the moment, I don't have any sprites. Yep. And finally, yeah, the player executes their turn, and the character who just had their turn reduces their turn meter by 100%, and they're taken off the queue. So it's a pretty straightforward system. Obviously, I'm not going really in depth in exactly what code I've written. Firstly, because this is just a quick prototype that I've made in a week, just to prove to myself that I could recreate the core concepts behind this game. But also because I don't think this is an entirely good reference to copy exactly. Though if anyone's interested in the source code, I would be happy to share that. I just need to separate the source code from the assets here, because these are paid assets and I can't share them. So that's it for this video. Thanks very much for watching, and I'll see you next time.